In this video, we are going to describe how to construct the domination tree and dominant frontier relations. So, assume that we are given the initial block ID and a control graph and the reverse control graph. So these are basically the graph, and this is the initial block ID. And the first thing to do is constructing the post order here, basically. So we are going to traverse the graph using the post order and reverse it. So we are going to get the reverse post order using it in this way. So traverse post order is simple. We are going to just have a data structure for tracking the traversal, which is consisting of the set of visited nodes and the set of traversal order, and then we are going to just traverse it. So basically, uh, it is traversing all the for each block. It is traversing all the um, all the next nodes basically, and mark it as visited in the traversal order. So that's the reason why it is called post order, because the BID is inserted to the order after all the uh, next nodes are traversed. So okay, so far so good. We traverse it using post order and reverse it to get the reverse post order or RPO. So it is just an inverse of reverse post order. So we are going to use it in the algorithm. And now we are going to calculate the immediate dominators for each block. So it is holding the immediate dominator for each block ID. And how to calculate it? So it is calculated in a loop where we are going to traverse all the blocks in a reverse post order here. And if it is initial block, we don't need to do anything, and it's just done. Otherwise, we are going to traverse for each block. We are going to traverse for each predecessor. And if the predecessor is the initial block or its immediate dominator is already calculated, then we are going to update the immediate dominator produced so far using some equation here. So recall that the immediate dominator is the intersection of the predecessor's immediate dominators. All right. So we are going to actually traverse for the predecessors, and we are going to get the we are going to calculate the we are going to check if the predecessor is predecessor's immediate dominator is already calculated, and we are going to intersect now the immediate dominator calculated so far with the predecessor here. And the intersection is defined as a tree order, in the domination tree. So we're going to see this in this code. So we have a reverse post order here, right? And we're going to calculate the intersection like this. So we are going to calculate the intersection of this LHS and RHS, and if they are the same, then the return value is obvious because intersection of A and A should be A basically. And otherwise, we are going to get the order in the RPO of both items, LHS and RHS. And if LHS is before RHS in the RPO or reverse post order, and you can be quite sure that RHS is um, later in the, I mean, and is bigger in the order. So we are going to reduce it by calculating the immediate dominator of RHS. So we are going to reduce RHS into the immediate dominator. Otherwise, if RHS is greater, then we are going to shrink it by replacing our LHS with the immediate dominator of LHS. So by doing so, we are going to get the intersection in the domination tree of this LHS and RHS, and it is returned here, basically. So using this algorithm, we are going to get the immediate dominator uh, of a node if and if it is well calculated, then we are going to update it. So if there was an entry and we are going to change it, then actually change it and mark it as changed. Otherwise, there is no calculated immediate dominator of this BID. Then we are going to just insert it, and we are going to mark it as changed. And if it is changed, we loop again because there can be something to calculate more. So it is a recursive algorithm. So we are going to update the immediate dominator array until no more information is added to this array. So, but if nothing is changed, then we're just going to break. And that is basically the recursive naive algorithm that calculates the immediate dominator. So the logic here is the most important here. So we are going to calculate the intersection of the predecessors, and the intersection is according to the domination relation or domination tree, basically. So basically, this is the algorithm for calculating the domination relation. And so far, so good. And now we are going to calculate the dominance frontier. Recall that dominance frontier is the set of y such that the y is not dominated by x, and there should be a z that is the predecessor of y, such that the x is either z or the dominator of x. Right? So the moral of the story is that we have to, so in order to calculate the dominator of x, we need to find such a z. But so that is basically the algorithm here. So we are going to traverse the control flow graph here. So here, let's say that the BID is actually y here. In this definition, we are going to say y here is a BID here. And here we are going to have a previous BID, and previous BID is z in the above equation here. So we now know that the z is actually a predecessor of y. We can be quite sure about that. And what we need to do is we check if the other conditions are met. And so this is immediately holds in this relation if you're going to get, I mean, so let me explain this way. Let's look at the runner here. At the beginning, it is the previous block, which is Z, and in the next iteration of this while loop, it becomes the immediate dominator of Z. And after the second iteration, it is going to be the immediate dominator of Z, and blah blah. In other words, the runner is actually Z union the dominator of Z, basically. So we are going to iterate for all the nodes that is either Z or a dominator of Z here, which is basically here. So we are going to look for a runner that is satisfying this condition here. So basically, runner is X here, and now the only remaining criteria here is like this. So we are going to check it, and if it is the case, oh, we can be quite sure that dominance frontier of X contains Y here. So Y is BID and the X is runner. So if it is the case, we can be quite sure that the dominance frontier of X should have a BID, which is Y. So this is basically calculating that. So this is the definition. And in order to efficiently calculate this, we are going to iterate for the counterflow graph and look for an edge where the predecessor is Z and successor is Y, and we are iterating through all the dominators of Z, and if it is the case, then we are going to insert Y into the dominance frontier of X, like this. In the dominance frontier of X, where X is runner, we are going to insert Y, where Y is the BID. So that is basically the algorithm here. And after calculating this frontier, dominance frontiers, we are going to return the immediate domination relations and dominance frontiers and reverse post order. So we are and later in the mem2res algorithm and the global value numbering algorithms, we are going to use this relation like this. So we can query the immediate dominator of a block, or we can query whether a block dominates another block, and we can query the dominance frontier of a given block, etc., etc. So that is basically how we construct the domination relation or domination tree and dominance frontier relations.